This is part 3 and the last part of the videos showing you a program that uses the AD converter. In the part 1 we looked at the hardware connections. Now once again in part 1 don't forget to connect V reference of the chip to 5 volts. Also we connect to port C bit 0 the wire coming from the sensor. In this case it's going to be a voltage divider, which is the middle connection of the two resistors. One of the resistors is the photoresistor, which measures the light in the room. In part 2 we looked at the software, which showed us how we could make one measurement or make continuous measurements. And the delay that we used between measurements was 1 millisecond, which is more than what is really required when you make the measurement. When you turn on the ADD converter, you must wait a certain amount of time so that the ADD converter can make its measurement. Well, we're waiting 1 millisecond in that example, and that's really much longer than what is required. Generally, you need 100 microseconds or even less to make a measurement, and we're waiting 1,000 microseconds. So if you want to speed this up, you can use this illustration of part 3 here. You can use this program to make the delay shorter, and thus you can make more measurements per second using this method. So if time is of essence to you and you want to make more measurements per second, then you may want to use this technique. So this program is available to you on the website. It's in complete form and you can look at it and use it. But let's go through this program, which has already been written. So we have in the program, at the beginning of the program, we have, before the main, we have a prototype, and the prototype is for this subroutine called ADD_328. This subroutine essentially turns on the ADD converter for us. We tell it the channel that we want to work with, like channel 0, and it turns on the ADD converter. Before this, right above it, we have a variable called ADD complete done, ADC done. And this variable is an integer. It's initially a 0. And if it's a 0, that flags us, telling us that the ADD converter is not finished in its measurement. When the variable becomes a 1, we know that the conversion is finished and we have our answer. This is a global variable, which means it can be used anywhere in the program. We need this. Also, we need to make it volatile. This keyword in C tells the compiler not to make any assumptions about the variable. For example, let's run down to where we use this. Here's where we use it, in this while loop. This loop says while you're not, and then the variable name. So while this is true, and true is a 1, so when this is a 1, we keep looping, which means that we keep looping while the variable ADC done is a 0. So while that variable is a 0, we keep looping, and we just count the loops. Now the compiler might say, well, in your loop, you're not changing the variable. And the compiler would make an assumption that since you're not changing the variable called done, this has no effect, and you'll have an infinite loop. So by making the variable volatile, it tells the compiler, don't make any assumptions, always test the variable for its value. So hopefully you caught that aspect where in this loop, it appears that the variable done never gets changed, but it can get changed via the interrupt. So we're going to loop here, right? We're waiting for the ADD to finish. And what's going to happen is, well, first of all, let's back up. In our program, we are going to allow interrupts, and then we do the DIDR0, the AD mux for the channel, and then we make one measurement. So the ADC SRA is going to be a 12. It's going to be a C8. I do believe that's what it is. But anyways, this bit that you see here for the one, that one right there, pertains to enabling the interrupt. So we must not forget to enable the interrupt in the ADC SRA. Okay, so but in other words, we are going to initialize the ADD right here. Allow interrupts, initialize the ADD converter, and then we are going to go into it what might look like an infinite loop, but it is not. This loop sits here and says, are you done? Are you done? Are you done? And it says, no, I'm not done. No, I'm not done. And when the ADD converter finishes, the interrupt will kick in. And that'll send us down here. So the ADD converter will kick in, and when the ADD converter completes and kicks in the interrupt, I should say, the interrupt makes this variable done a 1. So done becomes a 1, and this signifies to us and the computer and the program that the ADD converter is finished. Now done is a 1 here. When the interrupt returns to the loop where it came from, so it returns to here, and now it says done is a 1, and not 1 is a 0, and not 1 is a 0, like I said, and that's a false, and so we kick out of the loop. We're done. When that done becomes a 1, we finish the loop, and we finish, well, again, the loop, and we come down here and return the value of the ADD converter. Return ADCH. Well, I may have gotten ahead of myself a little bit here. Let's go back to the main program. The main program says this: initialize the screen so we can use the screen. And when we're done, we're going to display the results of the ADD converter on the screen. So turn on the screen, display the value of the ADD converter on the screen. And between the two, we say, go to the subroutine called AD328, use channel 0, and get a value from the ADD converter. So it runs down to that subroutine, which is where we were just at. And in that subroutine it says, okay, turn on the interrupts, allow them, I should say, initialize the ADD converter, as we should. One special note of initializing the ADD converter is this bit right here. We want to enable the A to D complete interrupt. So normally this register is either a E0 or a C0, but this time we're going to have a C8. If you need more information, please refer to the book. Upon doing that, we're going to go into a loop that waits for the interrupt to break the loop and set the value of done to a true, a 1. And when done becomes a true, we fall out of the loop, and we then return to the main program with a value from the ADD converter. So if you use this method, it takes about 56 microseconds to complete the interrupt, and to complete the ADD conversion, I should say. That's much quicker than using 1,000 microseconds or a millisecond. So this program is shown to you on the website. You can download it and use the version right there. So we'll end the video at this point.